Good afternoon. Welcome to the Space Station Deorbit Vehicle News Conference. Our event will begin momentarily. Today's conference is being recorded, and if you have any objections, you may disconnect at this time. If you are also monitoring the event video, please mute the audio on your TV or computer and listen only to the audio from the phone. If you would like to ask a question during the Q&A portion of the briefing, please press star 1 to be added to the queue. If you would like to withdraw your question, please press star 2. We ask that you do not use a speakerphone when you're asking your question. I will now turn our call over to your host, Ms. Sandra Jones. Ma'am, you may proceed.
Thank you, and good afternoon. Welcome to the Johnson Space Center in Houston, Texas. I'm Sandra Jones, and we appreciate you joining us today for today's Telecon to discuss the recently awarded U.S. Deorbit vehicle contract to SpaceX. Joining us today to discuss the U.S. Deorbit vehicle are Ken Bowersox, the Associate Administrator of NASA's Space Operations Mission Directorate, Dana Weigel, Manager of NASA's International Space Station Program, and Sarah Walker, the Director of Dragon Mission Manager for SpaceX. So we will first start with some initial remarks from each of our briefers before opening it up for questions. We will be taking questions on our phone bridge, so again, as the operator stated, please press star 1 to add your name to our queue and ask a question. So with that, I'll turn it over to Ken to begin his opening remarks.
Hello, everybody. Thanks for joining us today. Thanks for taking the time. It gives me great pleasure to be able to spend a little bit of time talking about the selection of SpaceX to develop and deliver a new spacecraft called the International Space Station Deorbit Vehicle. We've been working in low Earth orbit for over 60 years. You go back to Mercury, Gemini, some of the Apollo test missions, Skylab, Apollo-Soyuz, Space Shuttle, ISS, and then all the different vehicles that have flown to ISS. You can see how we've grown in our capabilities over the years and how our time in low Earth orbit has helped us prepare for missions to the moon and someday to Mars and even further. Work in LEO has been so valuable. I believe we'll have work to do in LEO for a long time into the future. It's just the most cost-effective place to work in microgravity. It's close to home. It only takes minutes to get there, and we can get a lot done for the resources that we have to invest. So I see a reason to be in LEO for a very, very long time. 25 years of that 60 years that I mentioned has been on ISS. Depending on what you're most interested in, people tend to see different things about ISS that are interesting to them, whether that's the international cooperation where we've worked with so many different countries, whether it's the thousands of experiments that have been conducted in microgravity, whether it's the human research, whether it's the assembly that we did showing how you can put together large structures in space, the exploration operations that we've practiced, or what we've learned about the human body and microgravity. All those things have been important and prepare us for the future. But 25 years is a long time, and we're getting to the point where we need to think about what comes after ISS. And to prepare for that, we need to plan for how we end the ISS program. So when I look at all the programs that ended in the past, I can see that something came after them, that something new and exciting came after every program that we've had previously. And I think we're going to see the same thing with ISS as we transition to the commercial LEO destinations in the future. And so it's exciting to me to talk about this deorbit vehicle. It's about the future. It's about what we're going to do out in the next decade. And it's about preparing for that future, preparing for what we're going to do with ISS, And so we can take our mind off what we do at the end of ISS and concentrate on getting as much as we possibly can out of it as we finish out the life of ISS. And now I want to talk or pass the microphone over to Dana Weigel so she can tell you a little bit more about the USDV and what we have planned for it. Dana?
All right, thank you so much, Ken, and thank you all for joining us today and for your interest in the International Space Station and, of course, in our recently awarded U.S. Deorbit vehicle. Station continues to be a very busy place, and it's fully utilized. We have a dynamic activity about every week to week and a half, so something like a visiting vehicle docking or undocking, spacewalk, robotics, a lot of busy dynamic activities. In addition to that, we keep the crew fully subscribed, conducting world-renowned research with hundreds of investigations that span across the globe. We do plan to continue fully operating the station through the end of its life. When we reach that eventual end of life, we will deorbit the space station through a controlled re-entry, and we will put it in some uninhabited part of the ocean. We haven't picked the exact location yet, but it will be in some very large uninhabited region. This controlled re-entry deorbit method is the same deorbit method that we use for other large spacecraft, like the Northrop Grumman Cygnus or JAXA's HTV cargo vehicle, so it's a very common operation that you would do to dispose of something very large. The deorbit itself is the responsibility of the entire ISS partnership, so that is shared across Roscosmos, the European Space Agency, JAXA, the Japanese Space Agency, and the Canadian Space Agency. The way the space station is designed, the Roscosmos segment has the propulsive capability both on board the segment and also through Roscosmos-provided cargo vehicles called Progresses. Early on in the station planning, we had considered doing the deorbit through the use of 3 Progress vehicles, but the Roscosmos segment was not designed to control 3 Progress vehicles at one time, so that presented a bit of a challenge. And also the capability wasn't quite what we really needed for the size of station, so we jointly agreed together to go have U.S. industry take a look at what we could do on our side for the deorbit. So we developed the concept of operations and a set of requirements for using a vehicle on the U.S. OS portion of station that would be docked to Node 2 forward. And then last fall, we released an RFP to U.S. industry to help us develop this U.S. deorbit vehicle. The vehicle's main purpose is to do the final series of burns that happen over about the last week of life of station as it's reentering. As you know, we recently awarded that contract to SpaceX. One thing to keep in mind is with any new vehicle development, it can be pretty complex and sometimes it can take a bit longer than what you expect. Historically, vehicles of this level of complexity could take 5 to 8 years to develop, and so we thought it was really important that we start now. The contract itself is different than other station crew and cargo transportation contracts where we're using a service-based approach. The other contracts for transportation vehicles have end-to-end services for transportation, meaning they cover launch all the way through operations of the vehicle. This contract is a bit different. This vehicle itself is being delivered to NASA, and then NASA has the responsibility to go and procure a launch vehicle and also to operate it. We'll do that launch vehicle procurement in the future using NASA's Launch Services Program. The USDV has such a critical function for us. Obviously, it's got to continue to perform critical burns, even if it encounters anomalies. So we require high reliability and a two-fault tolerant approach to the vehicle design. So in the RFP, one of the things we asked for is maximizing the use of heritage flight-proven hardware so we could increase the reliability. Of course, there is no existing vehicle that meets the high propulsive needs of the USDV, but we certainly can leverage hardware and systems that have been flown and tested in space already. The SpaceX concept leverages the Dragon vehicle, but about half of the vehicle will be new design, new development, and 100% of the new deorbit functionality that we need is new to the spacecraft. And I know Sarah will give you more details about that one when she talks. Ideally, we'd have the U.S. deorbit vehicle delivered well in advance of the station's end to life, as Ken mentioned. So the contract has what we call a dwell-in storage requirement in it. This allows us to deliver the vehicle early and then just store it and do periodic maintenance on it until we're ready to launch it. When we do make the decision to deorbit the station, we'll launch the USDV about 1.5 years before the final reentry burn. We'll dock it to the Node 2 forward port. We will do a series of checkouts. And then once we're convinced that everything looks healthy and we're ready, we'll allow ISS to be lowered down and begin drifting down. It takes a while to drift down. We think that'll be about a year to a year and a half in total of drifting down. We'll leave the crew on board as long as possible so they're available to help maintain the station and keep it healthy. Our plan is for them to leave about 6 months before the final reentry. As ISS reaches about 220 kilometers, the USDV will perform a series of burns to set us up for that final deorbit, and then 4 days later, it will do the final reentry burn. While we're preparing to be ready for the eventual deorbit of ISS, we're also very focused on continuing to fully utilize the platform and maximize the use. There's still a lot of new and exciting things we're doing on board the vehicle. There's still quite a bit to accomplish. We're also mindful that if we were in a position where we needed to extend ISS a little bit to avoid a gap in low Earth orbit, we also want to be positioned to do that. We'd really like an overlap between station and the next platform. As Ken mentioned, LEO is really an important place for us for a lot of the research and activities that we want to do, and it's very accessible, and it's a springboard and a jumping off point for what we need to test and learn for deeper space exploration missions. When the time does come to retire ISS, we'll plan to do an orderly transition from station to a commercial destination where we're hopeful that NASA will become one of many customers. In other station news, just a couple other quick updates. On Monday, June 24th, we had a spacewalk with NASA crew members Tracy Dyson and Mike Barrett. That spacewalk ended early because of a water leak in the suit's service and cooling umbilical. That's the side that's connected to ISS. We're still taking a look at the cause of the water leak and what we want to do to recover. We've got some equipment we're going to swap out, and so we'll go look for the next opportunity for where we want to do the spacewalk. It's not time critical or urgent, and so we'll find the best logical place to put it. Of course, Butch and Sunny are on board. They're continuing to enjoy their time, and we're appreciating their extra helping hands. They've done over 35 hours of research and utilization since they've arrived. It was really helpful to us when we were packing up the Cygnus cargo to get ready for its departure. We could have Butch and Sunny doing science while the rest of the crew was filling Cygnus with trash. That Cygnus vehicle departed station on Friday, July 12th, and then was deorbited the next day on the 13th. So we've appreciated having the extra set of hands on board. Around the corner, we're working towards our Northrop Grumman 21 Cygnus cargo resupply flight. That'll be in early August. And then, of course, not long after that, later in August, we will have the Crew 9 mission. And with that, I will hand it to Sarah.
Okay, thanks, Dana. Well, as Ken said, the International Space Station has been a global collaboration for the good of humanity for over 25 years. And for me personally, it's been the high point of my career to be able to support its operations in so many different ways. I was thinking as I drove up to Johnson Space Center to be with you this afternoon that most college students today have never known a day when it was not orbiting overhead every 90 minutes. With an onboard crew doing groundbreaking research benefiting life on Earth and exploration of the world beyond it. So SpaceX is proud to be a partner of all that the space station has contributed to the world already and all it will continue to contribute in its active operations phase for many years to come. NASA was one of SpaceX's first partners. They selected our team to help support an ongoing presence aboard the space station with cargo resupply services back in 2006. And then in May 2012, Dragon became the first commercial vehicle to visit the space station. And in the 12 years since, SpaceX's 43 Dragon missions to the station have helped ensure the continued operation of the station, delivering critical supplies, scientific research, new modules, new solar arrays, and 12 crews to the orbiting laboratory. One day, as we're talking about here today, and Ken and Dana have already said, the International Space Station will pass the baton to commercial stations that will become the next in-space platform for humans living and working in space. And when the station is ready to take that critical step, we are honored and humbled to be a part of it. We believe we bring a legacy of developing and testing and operating Dragon for over 17 years that will help us partner really closely together on that step as well. So the concept of operations for the Deorbit vehicle is incredibly complex, as Dana described. It requires substantial development to build a vehicle capable of such a mission. So it will ultimately take driving control of the International Space Station, so to speak, and propel the entire station into a precise deorbit trajectory that terminates in an unpopulated ocean area, so that any elements that could survive atmospheric reentry pose no risk to the public. So to achieve this, the Deorbit vehicle will need 6 times the usable propellant and 3 to 4 times the power generation and storage of today's Dragon spacecraft, just for scale. It needs enough fuel on board, not just to complete the primary mission, but also to operate on orbit in partnership with the space station for about 18 months. Then at the right time, it'll perform a complex series of actions, and Dana describes some of those burns and steps over several days to deorbit the International Space Station. So first, the Deorbit vehicle will perform orbit-shaping burns to put the station in a low elliptical orbit, and then eventually it will perform a final reentry burn to lower the perigee to intersect with Earth at the intended location. So the thing that I think is most complex and challenging is that this burn must be powerful enough to fly the entire space station, all the while resisting the torques and forces caused by increasing atmospheric drag on the space station to ensure that it ultimately terminates in the intended location. So the vehicle design will build upon SpaceX's operational Dragon cargo spacecraft with an enhanced trunk section that will host propellant tanks, engines, avionics, power generation, and thermal hardware tailored to complete this mission. So almost a spacecraft in and of itself attached there as a new trunk. So one of the benefits of leveraging Dragon's rich flight history is that we can continue to use NASA-certified hardware for a number of the key systems, like the docking system and propulsion system components like our Draco engines that were developed for our Dragon crew and cargo missions to the International Space Station, and that we have a long history of flying together with NASA. So while the assembly level design is uniquely developed for this mission, we intentionally use building blocks of components that NASA is familiar with and that SpaceX has extensive experience building and operating. So like all new vehicles that SpaceX develops, the new Deorbit vehicle will leverage the agile, innovative, and test-heavy concurrent engineering approach that SpaceX utilizes throughout development and leading up to flight. So no differences there. And just maybe a final word, you all know SpaceX's goal is to make life multiplanetary, and supporting space station operations has been an important step towards this goal, and safely deorbiting it as we collectively support the future of commercial space stations is the next step. So we're honored to have been selected for this contract, and we're proud to be a part of the continued evolution that makes humanity a spacefaring civilization.
All right, thank you to our briefers for those initial remarks. We will now open it up for questions. Again, if you are on the phone bridge, press *1 to submit a question. Once your name is called, please do state your name, affiliation, and to whom you'd like to direct your question. And if at all possible, please try to keep it to just one question so we can get to everyone. If you find that your question has already been answered, please press *2 to withdraw it. And our first question will be from Bill Harwood with CBS News.
Hey, thank you very much. I want to make sure, can you hear me?
Hey, Bill, we got you loud and clear.
Okay, hey, thanks very much. Well, I guess this is for Dana or Sarah. The picture you guys have put out of the vehicle, the DV vehicle attached to the forward of ISS shows quite a few engines at the back thrusting. Can you give us a sense of the number of Dracos on this vehicle? Do they all fire at one time? or do you use them in separate bunches? And what's the max DV capable of this vehicle? What kind of thrust can this thing provide? Thanks.
Sure. So I think your first question was about the engines. There are 46 Draco engines total. 16 are on the capsule already for attitude control. I think 30 for the Delta V maneuvers in the trunk. And your second question, could you repeat it?
Yeah, I was just wondering, of that total number of engines in the trunk section, do they fire at once in major burns, or are you just firing, clusters of those guys depending on what you need? And I was just trying to get a sense of the total Delta V the vehicle can provide. I know you said it's 4 times the thrust of a normal Dragon, but I don't know what that is. So if you could help me out there, I'd appreciate it. Thanks.
Sure. Yeah. So quite a few of those aft-facing Dracos are firing at the same time for that final deorbit burn. Somewhere between 22 and 26 of them will be firing at a given time to deliver about 10,000 newtons of thrust. And then the total Delta V that the vehicle has to provide was provided in the requirements for the contract. I believe it was 57 meters per second. So.
Thank you. Next up, we have Gina Sensori with ABC News.
Bowersox. Ken, you spent many, many months up on the space station. This must be a little bittersweet for you, and was there any thought given to how you might preserve some of the history up there, or will it all just end up in the ocean?
Well, thanks. Yeah, my time on ISS was wonderful, and I'd love to go back. I'm glad it's going to be flying for a while longer, so we can all watch it and think about some of the things that you brought up. Right, it's not too late for us to bring some pieces home. Unfortunately, we can't bring home really, really big stuff, but I'm sure there's some mementos that we'll get back and that will end up in museums someday. We'd like to be able to bring big pieces home, but the station really wasn't designed to be taken apart. It was designed to be put together, and it would be relatively expensive to try and bring something really large home. But I would love, the emotional part of me would love to try and save some of ISS, but the practical part of me realizes that using something like the USDV and bringing it safely back into the ocean somewhere is the most practical approach.
Thanks, Ken. Our next question comes from Marcia Dunn with the Associated Press.
Is it for sure the Pacific that you would be aiming for, or might it be the Indian? And in 2030, is that when you would abandon the station and start to really lower its orbit, or do you really want to see it down in 2030, barring an extension for some other reason? Thanks.
The South Pacific Ocean is one of the potential locations. Since we don't have to decide that now, we're still leaving that open, but that certainly there is a very large footprint there that we could use, but there are other locations that we're still looking at, so we'll decide that at some point in the future. In terms of the overall timeline and timing, there's some interesting variables that we don't control. One of them is solar cycle, and so we can control the launch of the USDV, the actual time that it takes to then drift down from where we fly right now to those final altitudes that I was talking about for the burn. That's a variable that's got a little bit of flexibility that we can't completely control. So our approach is we'll use some average estimates for environments, and we will kind of back up from the time of reentry. Right now, the normal plan or end of life at the end of 2030 means we'd splash in the ocean in January of 2031. And so based on the environment, we'd back up from that to pick the launch date. We expect low solar activity then, so it's probably about a year and a half before that we'd want to launch and dock the USDV. And, of course, the environments and the behavior of the solar cycle is something that we would watch and adjust dates as we got closer.
Our next question comes from Will Robinson-Smith with Spaceflight Now.
Much for taking the time to speak with us today. I guess going back to Gina's question, this one for Ken Bowersox. Once the ISS is put down in the ocean, I know obviously it would be far away from land, so this may be an expensive proposition, but has NASA thought about making an expedition to salvage whatever pieces may come back in larger chunks that could potentially make their way to a museum? Thanks.
That's a pretty good idea. I think there's going to be very little left based on our analysis when it hits the ocean, but it would probably be a good idea to go out there and take a look and just make sure when the time comes.
Thank you. Our next question comes from Elizabeth Howell with space.com.
Thanks for taking the time, everybody. Might be for Dana. It's an International Space Station scheduling question. So you had mentioned Crew 9, and as we all know, the FAA is considering a request to be launching Falcon 9 again under a public safety determination while the mishap investigation is still going. So anyway, I realize it's all FAA side, but I just wanted to ask from a procedural standpoint, would NASA go ahead with that? Just say, yep, the FAA is good and we're going to be launching Crew 9? Or do you have your own process to be determining when and if to be launching Crew 9? Thanks.
Yeah, that's a good question. We have our own process that's outside of what the FAA does. Of course, the FAA has got to finish their work and authorize SpaceX for launches separately. We take a close look. There are a couple configuration differences in the rocket between our configuration and other commercial flights. So we look at things like that. And of course, SpaceX is very transparent with their investigations. Not only is the FAA tied in and following along, but NASA is also included in following along. So we take an independent look at it as we determine our readiness for our launches. Sarah, do you want to add anything?
Yeah, you mentioned it there at the end. I was just going to mention that you guys have been in lockstep with us participating in the formal investigation process. I think I'm grateful that we have this framework to work through when you experience events like this, not just to figure out the specific cause of the issue that was observed, but the right actions to prevent it going forward, but also how it might be related to any other system, what separation there is between the configuration that was flying on that mission versus, as you mentioned, the configuration on Crew 9, et cetera. And so we're working through that entire process. We're keeping a close partnership with FAA and with all of our customers, and it's going really well. The team's made tremendous progress just in these first few days. Maybe I can just give a word or two on what we're talking about. If you weren't watching the webcast for last Thursday's Starlink mission, so we experienced an in-flight anomaly with the second stage engine. So first stage completed, it's part of the mission nominally. There's nominal separation of the two stages. And then the mission profile for a Starlink mission is there's a first burn, a coast for about 30 minutes, and then we restart, and there's a second burn. So the first burn also completed nominally, although we observed a liquid oxygen leak during that burn. So the burn continued to perform, or the engine continued to perform the burn through the leak, but the result of that leak and that long coast period that followed resulted in the second burn not being able to be performed successfully. So because the second burn wasn't completed, the engine kind of stepped through what it's programmed to do in these scenarios. So it deployed the satellites and then it passivated itself. But since the second burn didn't finish, they were deployed into a pretty low orbit. So we expect the orbit to decay relatively quickly from atmospheric drag. If it hasn't already, I think most of them might have already completed. So that's what happened last week. We know how to step through the stages of this process, and it's a joint investigation board, as I mentioned, between our government customers and the FAA and SpaceX chief engineers. So more to come there. And if there's any impact to near-term launch dates, we'll let you know. But right now, we're just trying to wrap up that investigation, and then we'll know if there's impacts.
Thank you. Our next question is from Joey Roulette with Reuters.
Thanks. For Sarah, I just wanted to quickly follow up on those comments you made. You said you guys are making really good progress on the Falcon 9 investigation. Do you know what might have caused the LOX leak, or what's your latest understanding into the fault tree and what all happened there? And then for Dana, real quick, could you quantify how much of the ISS will be surviving reentry and splashing down, making it its way to the ocean? Like how many pounds or what percentage of the overall structure? Thanks.
Yeah, so I think those are the details that I know right now. I know there's probably much more detail that when the investigation process concludes that we'll have and be able to share. This is our top company priority right now. And then as the Dragon team, my team, we just continue to progress through our nominal launch preparations for a number of upcoming launches on our manifest, so including Polaris Dawn, Crew 9, Sirius 31, and we're kind of standing ready for word that we're cleared to fly those missions. And Dana, if you want to talk about your part.
Yeah, let's see, in terms of space station dynamics during reentry, that the rust that we've asked for from the U.S. Deorbit vehicle will put us in a very, very tight debris footprint. And so what we're trying to do with a very large thrust and a very hefty burn is you can minimize, as a spacecraft breaks up, you minimize how far those parts can be distributed. So I think the first key thing is it'll be a tight and small footprint. That's the goal. In terms of the size of the pieces, I don't have it in total mass. I can tell you ranges of size of pieces. Some things will completely burn up, like the solar arrays are expected to completely burn up. Other very dense structures or structures that are kind of buried under structures can survive. I would say in the larger spectrum of what could survive, our assessments show that we could have things like the size of household microwave ovens, a number of pieces that are that size, and all the way up to the size of like a small sedan, like a car sedan type size. So there's kind of a range of numbers of pieces, and we have estimates in terms of how many of those types of pieces we think we'd have. But there are a lot of variables in play, including the orientation and the angle of the spacecraft as it's tumbling in and as it comes in. But again, all of the pieces that do make it through will be clustered together in a very tight footprint as they go into the ocean.
Thank you. Our next question is from Kenneth Chang with the New York Times.
Hi, thank you. This is for Dana. The Axiom module is supposed to be detached and then used for Axiom stations. I was wondering how that fits in with this timeline.
Yeah. So I think, as you know, right now on board, we actually have a docking port on the forward part of ISS. Before Axiom launches, our plan is to swap a docking and berthing port to put a berthing port at the forward. And so the actual activity to do that doesn't take that long. There's a couple of spacewalks and some cabling that we have to reconfigure both inside and outside. And so our plan would be at the end when Axiom departs, we'll go back into a reversed configuration and flip back to the docking berthing configuration that we're in today. So it probably takes, in execution time, it takes a few weeks to get that done.
Our next question is from Jeff Faust with Space News.
Question for Dana. When do you anticipate procuring the launch of the USDV? And given its size, is this something that could launch on a Falcon 9 class vehicle, or do you anticipate requiring a larger vehicle to launch it? Thanks.
Yeah, it's because of the amount of propellant it's carrying, and just as kind of a data point, I know Sarah talked about the 57 meters per second, but that's on the order of it's actually over 16,000 kilograms of just propellant. So you're up over 35,000 pounds of propellant. So in total, that spacecraft pushes us over just the normal smaller class rocket. So we've got to be on a heavier class rocket. In terms of timing, generally speaking, it takes at least 3 years before you fly. You got to really start your procurement for the rocket. We may do it a bit earlier for that, just to kind of have it ready and have it kind of on hold, but we wouldn't pull the trigger to actually go integrate the spacecraft and the rocket together until we're committed and ready to launch.
Thank you. Our next question is from Micah Maidenberg with the Wall Street Journal.
Hey, thanks so much. Ken, Dana, NASA evaluated a couple proposals. Were you surprised you just have a pair to look at, or was that expected or unsurprising given, SpaceX and Northrop's familiarity with the station? And then Sarah, would you expect SpaceX to be competing for that future launch procurement? Thanks.
Ken, do you want to start with that one?
Yeah, I'll take it. I was really happy that we got proposals from the companies that we did. The companies that sent us proposals are both great companies, and it was awesome to see that interest. I would have expected a few more, honestly, but I was very happy to get the ones that we got.
And I'll just add that, we did place an emphasis on flight heritage hardware, meaning flight-proven hardware. So, whether it's on the spacecraft that's flying today or some other spacecraft, the challenge, I think, to industry was trying to maximize the use of flight-proven hardware. So it doesn't completely surprise me that our current transportation providers who are already flying and compatible with things like docking to ISS, that they had a lot of heritage hardware to offer that was, closely aligned to what we're looking for. With Ken, though, I thought we might get a couple others, but definitely no surprise with the two we got when we look at what our request was to industry.
And just quickly, your question for me, yes, if the opportunity arises for SpaceX to launch the USDV, we'd happily support. We've got a couple different configurations across the Falcon product line, and believe we could support this mission. So we'll look out for NASA decision-making in the future on that.
Great. Our next question is from Stephen Clark with Ars Technica.
Hi, thanks for taking my question. I have a couple for Sarah. I think Dana mentioned earlier the total propellant mass on the USDV. Do you have a total overall, total wet mass of the entire vehicle at launch? Just how massive is this entire vehicle? And then also, Sarah, in the last few months, we've seen some reports of some debris from Dragon trunks making it to the ground unexpectedly. Curious what SpaceX is doing to mitigate that. Thanks.
Sure. I don't have the exact number in total mass, but I think it's pretty close to the number she was quoting. It's upwards of 30,000 kilograms for the vehicle. Dan, you're looking at me like you might know more.
Well, the prop alone is 16,000 kilograms, so you might be right that the total vehicle might be closer to the 30,000 kilograms.
Yeah. Okay. And then I think your second question was about trunk demise. So, yeah. So maybe backing up a little bit, just to round out that topic as a whole. So the majority of space objects utilize a relatively passive approach to disposal when their mission's complete, right? Drag causes the orbit of all space objects to get lower and lower over time into thicker and thicker layers of the atmosphere until eventually they're flying so fast with so much resistance that they break apart. And if they're small or have the right quantities of the right materials, they'll entirely burn up. So there's a complex model used by the entire industry to evaluate the size and shape and material quantities and confirm that the space object is expected to entirely demise during this atmospheric reentry process. So if this is the case, there's no need to design a propulsive deorbit system, for example, to land it in a specific location, like Dana was explaining some of the larger vehicles do, because it's expected to disintegrate before it gets there. This happens all the time for thousands of space objects. So there is known variability and uncertainty with this modeling approach, and I think the industry is constantly feeding back improvements to make those predictions more accurate. So as you're referencing, everyone's aware, there have been a few pieces of Dragon's trunk which were expected to fully demise, but that have made it to the ground. And so I just want to say we take this very seriously, and we've been partnering very closely with NASA and with the FAA for some time now on what our options are, what alternative solutions are available to us to ensure public safety on every mission. So more to come there. And then just to clearly separate from the topic of today's briefing, right? But because ISS is so big, NASA has always known that it will not fully demise, and they would need an alternative means of ensuring public safety, hence the plan to propulsively put it on a trajectory that terminates in an unpopulated location in the middle of the ocean. So, yeah, hopefully that answers your question.
Thanks. Next is Jonathan O'Callaghan with Aerospace America.
Great, thanks very much. Sarah, can I check, why is SpaceX using Dragon for this USDV instead of a Starship vehicle? And Ken, can you just clarify, how set is NASA on deorbiting the ISS? Is it 100% set, or is there a 2% chance the decision could be changed and it could be pushed into a higher orbit per chance? And a quick one for Dana, are the Progress vehicles now a redundancy, or is that plan scrapped entirely? Thank you.
Yeah, so to answer the first question, we looked at the requirements for this contract and what NASA needed for this deorbit vehicle to do, and this was the best solution that we found to work within those requirements. There's a range of thrust that it needed. Starship has too much thrust for meeting those requirements, so we wanted to propose the vehicle that would best meet the needs that the mission that they asked for.
Let's see, in terms of the Progress vehicle itself, the Roscosmos segment, so all the propulsion that's on board, both in the service module and then also what's available in the Progress cargo vehicle, still play a critical role. They will continue to be primary for normal vehicle attitude control, for debris avoidance, if we encounter debris on the way down. And then also, depending upon the fuel we have left at the end of life of ISS, they may help us a little bit with altitude lowering. And then in the very end, we're looking at if the U.S. deorbit vehicle encounters a contingency, though not ideal, with just 2 progresses, but that's what's normally available on the Roscosmos segment. We're looking at contingency options for a severe down mode in the event of multiple failures on the USDV to use what we have left on the Roscosmos segment. So still a factor, but not part of the primary plans for the critical burns at the end of life.
And then on the question on the end of orbit, end of life plans, I've never seen anything that's 100% in space, right? What usually happens is we constantly iterate and constantly revisit decisions that we've made in the past. So it wouldn't be surprising at all to me if in a couple years folks came in and took a look again at the work that's been done to try and decide what we would do at ISS end of life. That's pretty common with all our programs. And I honestly think they'll end up in the same spot. They might adjust the timing a little bit. Having a deorbit vehicle will give them flexibility and a little more certainty that they've got something that they can use when the time comes, whether they go a little bit earlier or a little bit later. But we've looked at lots of different options. The program has looked at lots of different options, and especially the raising option is one where you have to have all the data to really understand it. I asked about that when I first came back to NASA a few years ago, and the thing that surprised me is the orbital debris environment makes raising it problematic. We could actually make the orbital debris environment a lot worse because of impacts up at that higher altitude, increasing the amount of debris at that upper altitude, then having that debris come down eventually to a lower altitude. So again, the responsible thing we believe right now is to go ahead and bring ISS home all in one piece.
Thanks, Ken, Dana, and Sarah for answering that one. Our next question is from Issam Ahmed with AFP.
Hi, thank you. For Sarah, just based on the picture that we see that you guys put up, it does appear that the DV will be larger than your regular Dragon. Is that definitely the case, and do you have a sense of how much larger? And will it be entirely autonomously piloted, or will there be a room for sort of people to come in and make adjustments, obviously before the final before the final maneuver? And so also a very quick one for Dana. What's the resupply supply situation like right now on the ISS in terms of do the astronauts have enough of everything they need, given the sort of uncertainty right now about when the next Cygnus supply could come? Thank you.
Hey, so it is quite a bit bigger. I believe the trunk alone is about twice as tall as the standard Dragon 2 trunk. So you are observing correctly, and I suspect that the steering or the software, the control will follow the philosophy of all the vehicles that are flying today, which is some combination of functions that the vehicle performs on board and some combination that the controllers down in mission control perform.
I'd say in terms of resupply to ISS, we're actually in good shape right now with overall consumables, things like crew supplies, food, water. We do have a couple critical things that are coming up on the next flight. I've got my eye on a life support system replacement, spare component that I'm expecting to need not too long from now. And so, as always, each of these supplies is really critical to us, but we manage our consumables and our resupply by keeping about a 4-month reserve on board. That's kind of the general plan for contingencies. And so the general threshold programmatically is you can usually deal with up to about a 4-month slip. At that point, you kind of start running your reserves all the way down. So that's just kind of a good yardstick or way to think about it. But I am tracking a couple of critical components that I'd like to get on board pretty soon.
And so what are those components?
For life support system, for urine processing, if you recall, when we flew up Starliner, we delivered some components in that area to help with our urine processor, and I've got some more of that hardware on the Northrop Grumman flight that will help us get back into a normal kind of healthy configuration with our urine processor.
Thank you.
Thank you. Our next question is from Ryan Catan with NSF.
Hi, thanks. The image that you released shows what looks like, at least to my eyes, it just looks like a normal cargo Dragon with that new extra large trunk on the end. Will this be a previously flown cargo Dragon just with this new trunk, or are you going to be constructing a brand new normal Dragon vehicle with this new trunk on? Thank you. And that's for Sarah.
Sure. Yes. So the capsule portion will be a Dragon vehicle that we pull from our fleet, a cargo Dragon, and then, as you mentioned, the entire trunk section that is designed to perform this mission, which is different than all the missions we've performed so far, is entirely new design. So on the Dragon vehicles we fly today, the trunk serves a few purposes. It's kind of like a service section. So it has solar arrays that generate power for the vehicle. It has a radiator that radiates heat. Sometimes we take external payloads that are going to go on the outside of the space station inside that kind of empty shell of the trunk. So this trunk needs to perform a large amount of different objectives, and so that will be a new design.
Next up is Megan Bartels with Scientific American.
Hey, can you hear me okay?
Yes, we can.
Awesome, thank you. Megan Bartels with Scientific American. Super quick follow-up for Dana from Joey's question. What is the radius or diameter of that debris footprint you mentioned being super tight? And then a real question for Sarah. Does SpaceX expect to use the Deorbit configuration for other projects? Or if this is likely to be a one-off flight configuration, can you talk a little bit about the value in doing all this engineering, especially within a company that so prioritizes reusability? Thanks so much.
Let's see, the footprint for controlled re-entry that we target is 2,000 kilometers long. It's really narrow. I can't remember off the top of my head. They're really, as you can imagine, you're kind of accelerating forward very quickly, as you're re-entering. And so really the debris tends to kind of lay out in a very narrow, kind of long path. And so our footprint will limit that path to 2,000 kilometers or slightly less.
Great, thank you.
And to your question, yes, this vehicle will be one-off, but it does provide a lot of value to it. Well, I will say it is one-off, but it builds upon technologies and hardware that we're currently flying, and I think that those benefit each other. That us continuing to operate the Dragon fleet will give us more and more data to inform as we're developing this new vehicle and what improvements we might want to roll in as we go along, and then vice versa, the development of this new vehicle will surely help us discover things that we may want to roll back into the operational fleet. And so, yes, the vehicle's one-off, but I think that there's a lot of back and forth between our current operational fleet. And for me personally, I think more of the value of doing this is it's a wonderful full circle experience, I think, for me and for SpaceX with partnering with ISS all of these years, to go from being the first commercial vehicle to approach and attach to the space station, all the way through when they're ready to pass the baton to the next platforms that will come after. And so, yeah, I can't express enough how honored we are to be a part of that step.
Thank you. Our next question comes from Marina Koren with The Atlantic.
Hi, question for Ken and Dana. Are you planning to recover anything from inside the ISS before deorbiting, such as equipment or mementos? And if so, do you envision contracting SpaceX to do Dragon return missions specifically aimed at bringing those items home, basically acting as movers to empty out the station? Thanks.
I'll start, and then Dana can jump in with more details, but there's some little things up on ISS that I think we'll probably want to bring home on the last cargo Dragon that comes down. I can't see us affording any dedicated missions right now, but for example, the ship's bell, ship's logs, maybe some panels that have patches on them, some display items. There may be some technical hardware that needs to come down and would be useful for research purposes or technological development purposes. But Dana, you probably have thought through it a lot more.
No, I mean, I think Ken's exactly right. We don't really have the disposable income for dedicated missions for bringing hardware home. What we will see as we get closer to the end of life, the number of spares. Today I return a lot of hardware, refurbish it, because that's very cost effective, and then refly it as a spare. And so at the end of station's life, of course, you don't have a specific driver to return it for the purposes of refurbishing it, so it opens up more flexibility with what we choose to bring home. If there were, there will be a lot of things I think that people are interested in, whether it's from a memento standpoint. There could be some things that are useful to researchers, for example, who want to get more things home, or things that play forward to a future platform. So it's really work in front of us to decide, and we have plenty of time to do that, what we want to bring home. What we're really looking at is, as our resupply flights towards the end are more focused on just kind of the final deliveries, the return manifest needs really change, as you don't need to bring home spares to refurbish them anymore. So that's going to free up some space for us.
And in terms of bringing people home, is there a specific time you have in mind for when the last crew member leaves and when you would start that deorbit, whether for safety or planning reasons?
Yes, our current plan has us doing our final crew exchange right before we launch the U.S. deorbit vehicle. So we'll do a crew exchange, we'll get a fresh crew on board, we'll launch the deorbit vehicle. Of course, that will then occupy both of our docking ports. I've got a crewed vehicle on one port, the U.S. deorbit vehicle on the other port. Once we check out the U.S. deorbit vehicle, we'll start drifting down. So the crew will actually drift down with us. We won't go much below 330 kilometers with the crew, because that's about where the crewed vehicles, their certification range is. Our expectation is that we'll hit that point about 6 months before reentry. So the crew will ride down for a while as we're drifting down, and then they'll depart about 6 months before.
Our next question comes from Douglas Gorman with Payload.
Yeah, hi. Can you hear me?
Yes, we can.
Yeah, great. So I just had a question on, I think it was Dana's comment that you were going to be waiting until another commercial space station was up to bring ISS home. If you could just give us any details on that regarding either how that affects the timeline, if another commercial vehicle can't get up there, or what kind of commercial space stations you envision being up there in time to do the passover? Thank you.
I think Ken can help with some of the higher level context. I'll give you just some thoughts specific to the end of ISS. What we will plan to do, obviously as a goal, we'd really like to have some continuity to what we're doing in low Earth orbit for any number of reasons. One of which is we've done a fantastic job building up a transportation capability across the commercial industry. We've built up a great, robust research capability, and of course we've got a lot of international partners. And so the desire is really to make sure you keep continuity and keep those, I'll say, swim lanes in different areas really healthy. And so we'd really like to see these commercial destinations up and flying and functional to some extent so that we have a smooth transition between the two. As we get closer, we'll come up with looking at more specific criteria to align it to decisions that we're making on the ISS side to make sure that we're aligning those well. And I will hand over some of the bigger picture thoughts to Ken.
Yeah, I'll just say that our main goal is to avoid any type of a separation between ISS and the platform that comes next. We'd love to have some overlap, but there's lots of things that could keep us from being able to do that. Resources is one, development schedule for the new vehicles is another. We're going to make sure they're ready before they fly them, and we wouldn't want to hurry them up. And then just how things are going with ISS, that's another possible factor. So we'll be weighing all those things and doing our best to minimize any type of separation between the current platform and the platforms that come next. As Dana mentioned, a big factor in that, it's the research pipeline, the cargo transportation, the crew transportation, trying to make sure that whole system is healthy and ready for the new platforms. So we're thinking a lot about the transition. We're trying to manage it to minimize any type of disruption, and we'll use all the flexibility that we've got to avoid a disruption, but we'll have to react a little bit to how the situation actually develops.
Our next question is from Marcia Smith with spacepolicyonline.com.
Thanks so much. My question is for Ken, and it has to do with the funding for this. Could you tell us what your current estimate is for the Deorbit vehicle plus launch, and over what period of time that is? And with the sharp funding constraints going on in Washington right now, what is the outlook for you getting the money that you need in these early years? And specifically, I don't think there was anything in the appropriations for fiscal 24, but were you able to channel some money for fiscal 24 in the operating plan, or how much do you actually have in 24?
So we were able to get a small amount put into the previous year's appropriation, so we have clearance to move ahead with the program. And the next step is to try and get the full funding if we can. The administrator's been quoted that he's trying to get $1.5 billion to fund purchase of the U.S. Deorbit vehicle, the launch, and all the other associated costs that could go with the Deorbit. The actual cost of the vehicle from SpaceX is a lot less. But less than half of that 1.5, or say on the order of half of the 1.5, depending if we need to do any extra items working with SpaceX during the development. And then the launch vehicle, those are typically on the order of a few $100 million. And then the rest is integration costs and other reserves to make sure that we'll be able to do it. We've asked for, in a supplemental, $180 million. That's out there in a supplemental that's awaiting action by Congress. But if we don't get that, this is important enough to us that we'll have to take it out of our current funding, and it could affect ISS operations.
Do you have any indication from the Hill so far if they're going to support your fiscal 25 request?
The Hill is very supportive, and we've gotten tremendous support from the executive branch and from the legislative branch. But as you know, even really critical legislation can take a while to work through the Congress right now. So we're being patient and letting them do their job and expecting that they'll bring it forward here pretty soon.
Our next question is from Jim Siegel with Florida Media Now.
Hi, everybody. Thank you for taking my question. Jim Siegel from Florida Media Now here. I understand that the plan all along had been to eventually deorbit the ISS when the commercial space stations came aboard. But my question is this: suppose some organization came along and said, you know, we would like to use that ISS for another 2 or 3 or 4 years or whatever, you know, it might be. What are the specific issues or limitations that would prevent that kind of thing from happening, if at all? Thank you.
Let's see. Ken, maybe I'll start with kind of the assessment that we did when we did actually look at the potential for seeing if there was industry interest in kind of managing and flying ISS. We did some work, I don't know, maybe this was 6 years ago, just gauging industry or other entities' interest perhaps in, at the end of ISS life, taking over and managing and operating ISS. And we learned a number of things back and forth with the industry. But one of the complicating factors with ISS is, of course, it is in aggregate a combination of many different suppliers who have helped to build it, many different countries. So there isn't a single focal point where you can just kind of hand over a data set. And though NASA owns some portion of the data, we didn't actually go procure it or put it together in the sense that you would be able to go hand it to someone to go operate it. And so what we learned from that is the supply chain, the number of different entities involved is so complex that it ended up not really being a practical thing to kind of hand off to someone else. If you think about, just as an easy example, on the USOS, the US segment, we've got the really large solar arrays, and so we're providing power for the Japanese, for the robotic arm. So we're kind of the power provider, and also for the Roscosmos segment. But over on the Roscosmos segment, they're providing all the propulsive capability. And so the spacecraft is really built and designed to be integrated across all of these parts and elements and functions, including the robotic arm, which is really critical to maintaining the vehicle. So it's not just as simple as just kind of taking over all the parts, because a lot of different entities still own pieces of it.
Okay, good answer. Thank you.
Yeah, I think I'll just echo Dana there. One of the critical factors is just coordinating with all our partners. It's not just our decision on what we do with ISS if we were to decide to fly longer. And we need to coordinate with all the other branches of government that help provide guidance for us, all of our other stakeholders. Right now, we've got clearance to operate through 2030, and that's as far as we have clearance. We would need to have approval to go beyond that. And, like I said, cooperation of all our partners.
Okay, thank you.
Thanks. Our next question comes from Yuichiro Inakuchi with Kyodo News.
Hi, thank you for taking my question. My question is to Mr. Bowersox. I want to know if the participating countries have already accepted or approved the retirement plan of the ISS, including Russia. Also, are you expecting any contribution from the partner countries like Japan for the safe retirement of the ISS? Thank you.
So I can let Dana give you more particulars on specifics, but in general, all the partners share the deorbit responsibility in proportion to the mass of their systems and elements that are at ISS. we've coordinated and continue to coordinate with all of our partners. I think final approval is probably a strong way to describe it, though. We still have more discussions as we finalize the plans, but they're all aware of our work with the U.S. Deorbit vehicle and all agree that moving forward with this Deorbit vehicle is an appropriate way to proceed. Dana, anything you want to add?
No, I'll just add that, after we announced our selection, we did actually get together with all of the partners. We held what's called the Space Station Control Board, and all of the program managers from the different partner agencies met, and we gave them a good overview. Of course, in the formulation, the concept of operations and the approach was shared, and we were able to recently share a little bit more detail. And so the partnership works with us. And like Ken said, there's a lot of implementation details that we'll work through later, but the partnership is in agreement with the overall plan. And then typically for contributions, they will each technically owe a contribution based on the percent of the mass they have on board. And as I think we've shared before, they like to do that as an in-kind or a barter type exchange for value. And so that's also work in front of us with each of the different partners.
Our next question is from Robert Perlman with Collect Space.
Thank you. Working off some of the earlier questions about bringing items down, the white paper that NASA put out about this process mentioned that you've engaged the Smithsonian and other organizations, and I wonder if that includes the international partners. Will NASA be taking requests from its partners, including Russia, to bring certain items back down for historical preservation? And Ken, you mentioned that that you don't see reserving down mass capability, more or less using available capability to bring down these items. Do you see the ranking historical preservation over extending science operations to the last minute? So if the Smithsonian, for example, says they wanted a glove box or part of a glove box, or Canada said they wanted part of the Canada arm, that you would disable part of the space station for preservation? Thanks.
So I think our partners will want to have that discussion with us, and I think everybody will have something that's important to them that they'd like to talk about bringing down. The same thing goes with some of the prioritization between science activities or bringing back some of the preservation items. ISS has a really good process to work through some of those questions, and I think as we get closer, we'll have a list, and they'll go through, figure out what's capable, and figure out how to maximize the return to everybody who's interested in whatever is there as we prepare for the end of ISS. And our partners, depending on how things develop there, we could see that there's more than one way potentially to bring items home from ISS. We certainly have the Russian Soyuz as an option. We've got the Dragon as an option now, and our ESA partners have talked about having something that's available to bring items home. So we would all work together to maximize the return for the whole partnership.
I would just add that each partner in our barter arrangements and agreements, each partner on the USOS, so ESA, JAXA, and CSA, they're given allocations for both upmass and then also return capability. And so, each partner can work within their own allocations for what they want to do. And then, like Ken said, if there's something beyond that that they want to discuss, we'll all get together and have a discussion. We don't have prearranged agreements like that with Roscosmos. Since they have their own vehicle capabilities, and as Ken mentioned, Soyuz has return capability, that's much less likely. That's not something that's a normal part of the exchange and kind of barter arrangements in the program.
Our next question is from Manuel Mazzanotti with Exploración Espacial.
Thank you. Manuel Mazzanti from Exploración Espacial. I guess a question for Dana or Ken. You mentioned before that there's the idea is to avoid a gap between the deorbiting of ISS and new commercial space station. But I'm assuming this is directly related with the Axiom space timeline, or I mean, if they get delayed for some reason, the potentiality of having an extended life of ISS is getting more real. And if that's the case, how far beyond 2030 can you go? That's my question. Thank you.
It wouldn't just be Axiom. We've got 3 partnerships that we're working on right now. Blue Origin, Starlab LLC, and Axiom, and then all their partners. If we could get any one of those available before ISS is ready to come home, that would make me pretty happy. Again, as far as the date, any extension, we would have to coordinate with all our partners and with all of our stakeholders outside of NASA. So that's not something that we would start at the last minute, right? That would have to start pretty early in order to work in that into the plan. If we get to that point and didn't get an extension and it takes longer to get the new platforms, we would take whatever steps we could to minimize the impact of that gap, right? So I don't think it would be something that is unsurvivable, but it's something that we would like to avoid just to maximize efficiency. Dana, anything you want to add?
No, I think that was a good summary, Ken.
Thank you, Ken. I was asking because of the Axiom is the only one that is going to be using the ISS as a platform. That's why I thought it was strictly related, but thank you.
Yeah, we're
Thank you.
thinking about all the platforms. That's right.
Thanks, Ken. Our next question comes from Anthony Colangelio with Main Engine Cutoff.
Hey, thanks. For Sarah, is there any commonality between this Dragon vehicle, I don't know if it has a name, and Dragon XL? There are some out there doubting the existence of Dragon XL, so it would be cool to hear if there's any commonality and what the status is for that vehicle as well. Thanks.
Good mention of another vehicle that is being developed for a very specific mission. So I would just say each of these Dragon variants or evolutions are designed for the mission that they have to accomplish. Dragon XL needing to go to deep space, needing more radiation protection, power storage, things like that. This vehicle needing a ton of propellant, a ton of engines to provide a lot of thrust to push the ISS. So I think there's commonality in all of our spacecraft, and we learn a lot one from the other and try to apply lessons learned across all of our fleets. But you're right, Dragon XL is a bit unique, like USDV is unique.
Next question is from Leo Enright with Irish TV.
Thanks very much. I'm just curious, was any consideration ever given to using the European Automated Transfer Vehicle? I mean, the original NASA deorbit analysis for 57 meters per second DV was in the ballpark of 9 tons of propellant. Now, I know Dana has cited a much bigger figure, but I'm just wondering, that would be in the ATV ballpark. So was it ever considered?
You know, I don't know if there were really early discussions. Certainly they would have been before my time. I would tell you in the last at least 12 years since I've been in the program and part of the program, the focus has really been heavily on progress. That may be because ATVs weren't flying anymore and that line was no longer open. It also may have been, very early on when we were looking at the Progress vehicles, we were optimistic that it would meet the needs. And of course, ISS did grow over time. There were a lot of changes that changed our understanding about what we would need. So I think that all evolved and we realized that Progress wasn't an ideal option well after ATV had been retired and not flying anymore.
Next question is from Jack Kerr with Payload. Jack, if you're speaking, we can't hear you.
Hi, can you hear me?
Yes, now we can.
Yeah. My question was answered with the Dragon XL question, so thank you.
Okay, great. Our next question comes from Ken Kramer with Space Up Close. Ken, we also can't hear you if you're speaking.
Can you hear me now? Hello?
Yes.
Okay. Yeah, my question's for NASA. Thank you. I'd like to know about raising the orbit. I want to go back to that question again. Are you actively looking at any potential extension by raising the orbit at all, or have you totally given up on that idea? Because I ask because these commercial stations with the budget cuts could be delayed. So I'm very concerned about that. The other thing is that NASA, other uses of this USDV. I know SpaceX said something, but what about using this? It seems like a great capability. What about using this for science probes or Mars sample return? You're looking out of the box for other solutions to that. Would you consider that at all? Thank you.
Let me start with the first part about the raising the orbit. And if I understood your question, that was more tied to extending life of ISS versus retiring it. But just to make sure I kind of hit both, I think Ken kind of explained why there are considerable challenges. The energy cost, obviously, for going up is much, much higher than coming down, and what you'd have to do to get to a safe, higher orbit is substantial and with increased risk as the micrometeoroid environment goes up. But in terms of just for extending life, we actually have talked about how do you optimize and where do you fly, and could you fly higher to reduce the demand on propellant delivery. So we have looked at some trades there, and because we fly where we fly, all of our vehicles and our spacecraft and their propellant tanks are all basically sized for kind of where we are. So we've actually looked at both ends, both for disposal and just for kind of optimization of flying, and neither one really made sense. And I think Sarah will take the second part in terms of extensibility of the USDV. I mean, just from my knothole, from a NASA standpoint, when we've talked about it, we certainly recognize that in staying in LEO, this whole discussion about how do you safely dispose of vehicles at the end of the life will kind of persist into needing methods like this. And so I can imagine future fieldies leveraging, whether it's a Dragon baseline or not, but capabilities very similar to this.
Yeah, that's a great idea. We've certainly developed vehicles for specific capabilities that we wanted to go accomplish, and then discovered later new applications. So you're right. Depending on the size of future space stations, they'll end up with the same needs, and so anything's possible.
And our last question for the day is going to be from David Curley with Full Throttle.
It's a variant. I understand it's a custom bespoke kind of vehicle, additional Dracos, additional propellant. Can you detail why a vehicle like this is going to cost the kind of dollars you talked about?
Sure. So I think I've talked about the complexities of the vehicle itself. I think there's also a number of complexities that come with actually pulling off a mission like this. So one example is I mentioned that one of the most complicated parts about the deorbit burn is that it has to be continuing to operate in a different environment than we're used to operating while pushing ISS with all of its appendages, right, that are having increasing drag on them, and those cannot thwart it from its mission of getting it to the target location. And so NASA did a lot of planning on the fault tolerance approach for something like this, and that's something that we have to go think about together. I think you'll see in the request for proposals for this contract that there's also a number of unique, I would say, not contingencies, but there's unique aspects of actually going and doing this that NASA planned in advance for, things like dwell time to have the vehicle ready ahead of need, or as we've been talking about, the exact timing being uncertain of exactly when its operation will happen, storage capability to extend out further. It has operated in space much longer, which is a new capability to be developed that's several times what we do today. NASA is looking at what kind of critical spare strategy they want us to have for any number of contingency scenarios where you would need to have long lead parts in production to provide a contingency vehicle or elements of a contingency vehicle. So all of these things, I think, add up to the articles that you see, but it represents a lot more than what meets the eye.
I think I would just add, maybe I probably should have put this in my opening remarks, but when space station starts dropping below that 220 kilometer point, we will have a very hard time managing a lot of our systems, and though we don't know exactly when things will fail out, we do know that we will start seeing performance loss in a number of areas. Power is one. Our vehicle will start heating up quite a bit more. We expect to lose communications capability as we're going down. And so one of the really unique things that we had to do with the Deorbit vehicle is ask that spacecraft to independently take care of all the capabilities needed in the last 4 days of Deorbit. Today, when visiting vehicles come and dock to us, we provide them with power, data, communications. They can go through us to get to, for example, the TDRS satellite network. But because we know that we'll start losing functionality as we get kind of draggier and interacting more with the atmosphere, we had to levy on this vehicle the capability to be completely independent and take care of all of those assets that ISS normally supplies the services for. So that's another unique element with this vehicle.
And thank you to all who did submit questions today, and thank you to Ken, Dana, and Sarah for their time and even going a little extra over to accommodate all the questions we received. You can continue to follow along for more updates on our social media platforms, blog, and online. But for now, that will do it for us here. Thanks so much for joining.
This does conclude today's conference call. We thank you all for participating. You may now disconnect and have a great rest of your day.